the idea is that you have this electrode, this glass pipette inside the cell, and you're going to record using your electrode amplifier. But there's a resistance associated with that because nothing's perfect. The electrode is not a superconductor, and so we have this fixed resistance. Now, whenever you have a conductive solution, like inside the pipette, and another conductive solution outside the pipette, and a very thin insulating region between them, which would be the thin glass of the glass pipette, and parenthetically, I should say that these pipettes are micron diameter, or sub-micron diameter. That's how they get into cells. So you use a hot wire to melt the glass and pull it into a fine pipette. And so the pipette tip is very, very small and very, very thin. Well, the consequence of that is the pipette has capacitance, because that's what you get when you have two conductors on either side of a dielectric. Well, the problem with capacitance, and you add resistance to it, and instantly you have a filter. You have a filter because that resistance capacitance forms a resistor capacitive time constant. And so the RC time constant of the electrode totally limits how fast a signal you can record from a neuron. And so our knowledge of how fast action potentials rise, say the speed of that, is a little bit hampered by the fact that we can't measure it infinitely quickly using a glass pipette electrode. And so there are very much limitations in that technology in terms of the speed with which you can record an electrical signal.